Pantheon AI presents Earth-Trapped Cosmic Void Discovery.
Okay, John. Have you ever just looked up at the night sky and felt incredibly small? Well, get ready to feel even smaller, and maybe a little bit empty.
Oh, Sarah, you're setting me up for something big here, aren't you? Pun intended. What cosmic revelation are we diving into today?
Exactly. So imagine this. Scientists are now suggesting that Earth, and even our entire Milky Way galaxy, might actually be living inside a gigantic cosmic void.
A void? Like an empty space? That's quite a premise. What exactly does cosmic void even mean in this context? Is it just nothingness?
That's a great question, and it's not quite nothingness. Think of it as a region of space that's significantly less dense than the average universe. So fewer galaxies, less matter, just more emptiness compared to the cosmic average.
So less crowded, essentially. But how would scientists even begin to figure out something like that? It sounds like trying to weigh a cloud.
It really does, doesn't it? Well, they're not just guessing. One of the key pieces of evidence comes from something called baryon acoustic oscillations, or BAOs.
Baryon acoustic oscillations. That sounds incredibly technical. Can you break that down for us, Sarah? What are those, and how do they point to us being in a void?
Absolutely. Think of BAOs like frozen sound waves from the very early universe. Back then, the universe was incredibly hot and dense, and sound waves actually rippled through it, much like sound through water. When the universe cooled, these ripples essentially froze in place, influencing where galaxies would later form.
Fascinating. So they're like cosmic fossil records of the early universe's structure?
Precisely. By studying the distribution of galaxies today and how they align with these quote, ancient biopatterns, astronomers can map out the universe's large-scale structure. And what they're finding is that our local region appears emptier than expected, which aligns perfectly with this void hypothesis.
Wow. So these ancient sound waves are telling us we're in a less dense area. But you mentioned something earlier, a Hubble tension. Is this void idea connected to that?
Oh, it's absolutely connected, John. This is where it gets really interesting, because this void hypothesis could actually solve one of cosmology's biggest puzzles, the Hubble tension.
The Hubble tension, right. For listeners who might not be familiar, can you explain what that is? Because it sounds like a cosmic disagreement.
It totally is. So basically, we have two main ways to measure how fast the universe is expanding. One way is by looking at distant galaxies and their redshift, and another is by looking at the cosmic microwave background, which is light from the early universe.
And I'm guessing these two measurements don't agree?
Nope. They give us different expansion rates. The universe seems to be expanding faster when we measure nearby galaxies compared to what the early universe data predicts. It's a significant discrepancy, and it's been baffling scientists for years.
So how does being in a void resolve this tension? Does the void somehow warp our perception of expansion?
That's a fantastic way to put it. Imagine you're in a giant bubble. Around that bubble, there are denser regions of space full of more galaxies and matter. These denser regions exert a stronger gravitational pull.
Okay, I'm picturing it. A cosmic bubble with us inside and denser stuff all around it.
Exactly. Because of that stronger gravitational pull from outside the void, galaxies co-orbital within our void, including our own, would be pulled outward more rapidly. It's like being on a slide that's accelerating downwards because of the weight around it.
So the local universe appears to expand faster than it actually is, or faster than the overall cosmic average, because we're being gravitationally slingshotted out of this less dense region. That's a clever solution.
Right? It makes the local universe look like it's expanding at a higher rate than the global average, effectively explaining that, quote, tension between the two measurements. It's a neat trick of cosmic perspective.
So if this model is confirmed, what does it truly mean for us living inside this less dense cosmic neighborhood? Does it impact anything tangible, or is it purely a theoretical resolution?
Well, it profoundly changes our understanding of the universe's structure and its expansion, doesn't it? It suggests our little corner of the cosmos isn't just average, but actually quite unique.
It certainly adds a new layer to cosmic cartography. And if it truly resolves the Hubble tension, that's a monumental step forward in cosmology.
It really is. It means we might be closer to a unified understanding of the universe's expansion history. Plus, It's just mind-bending to think we're floating in our own little cosmic bubble, isn't it?
It's a humbling thought, Sarah. And it makes you wonder what other hidden structures are out there, influencing everything we see. What's next for this theory? More observations?
Absolutely. More data, more precise measurements, and continued analysis of those BAOs and other cosmic tracers. If this model holds up, it'll reshape our cosmic map in a really exciting way.
Fascinating stuff. Definitely gives you a new perspective on our place in the universe. Thanks for breaking that down, Sarah.
My pleasure, John. Always happy to explore the cosmos with you. Pantheon AI, your information co-pilot.
Because learning shouldn't feel like a full-time job. Take care and see you next time.